Hi everyone, this is a video guide to FRC Pneumatics. There is a corresponding quiz that goes along with this video, so please have it open as you're watching. First, let's go over the basics of pneumatics in general. Pneumatics is a branch of engineering that uses pressurized air. This air is then used to operate devices such as pneumatic cylinders or pistons. This works by first compressing air and storing it at a high pressure. Pressure is a measure of how much air is packed into a specific volume. Think of the example of a syringe. If you plug the end of the syringe and squeeze it, that air inside will be at a higher pressure than what it was before, and you'll feel that force exerting against your hand. Once the compressed air is stored, it is then directed to our pistons or pneumatic cylinders, which extend or retract based on where the air is directed. A visual of how this works can be seen here. In FRC, we use pneumatics to achieve linear motion. Although we have things like motors already in our toolbox, these achieve rotary motion. Now, let's look at how we can create a pneumatic system using FRC parts. First, we have tubing. This is standardized in FRC and is used to connect all of our pneumatic components together. There are also several other tools that we use for connection like T-connectors, but it's somewhat difficult to explain how to use them over a video. Next, we have the pressure gauge. This tells us the pressure of the air at a specific point in the system. This is measured in PSI, or pounds per square inch. The higher the PSI of the air, the more pressurized it is, and thus the more powerful our pneumatic system will be. The pressure read on the pressure gauges are not the actual pressure, but rather the gauge pressure. Gauge pressure is measured relatively, which means it considers atmospheric pressure to be 0 psi. Atmospheric pressure is the pressure that you feel that the air exerts upon you when you're just standing around. So when the gauges are not plugged into anything, it will read a pressure of 0 despite there actually being atmospheric pressure. Next, we have the air tanks. These are simply empty containers that can store air in them, but allow us to store a higher volume of compressed air in our pneumatic system. The bigger our pneumatic system is, the more air tanks we need. Next, we have the compressor. This takes air from the atmosphere and compresses it, and then feeds it into our system. This is a one-way gate, so any air that is fed into the system through the compressor cannot exit out through the same way that it entered through the compressor. This means that we need other methods of releasing air in order to calibrate our pressure to what we want. One of the ways we do this is through our pressure relief valve. This is mounted directly on the compressor most of the time. The pressure relief valve is calibrated to a certain pressure, usually 1 to 5 psi, and whenever it exceeds that amount, it lets air out, thus decreasing pressure back down to a safer amount. This is very important to have for safety reasons, as high pressures can be extremely dangerous. Another way we can do this is with the pressure switch. The pressure switch is a device that turns on and off the compressor when it reaches a certain PSI. For example, a pressure switch may turn off a compressor when it reaches 120 PSI and re-enable it when it goes back down to 90. Thus meaning that our air in our system will always be stored at somewhere around 90 to 20 psi if we were using this pressure switch. For analog pressure switches, which we will be using this year, we can set this range manually in our code. We also have the pressure regulator, which is another device that allows us to control the pressure of the air in our system. But this device is unique because it allows us to maintain a different pressure on the input side and output side of a regulator instead of just changing both by the same amount. This is very useful because it allows us to have high pressure parts of our pneumatic system as well as low pressure parts of our pneumatic system. Next, we have solenoids and pistons. Solenoids allow us to control the air that is being directly fed into our pistons, allowing us to extend and retract them. Double solenoids, which are what we generally use, have two sides, hence why they are called double. You can think of them as a flipping switch. You can only have one of the two sides active at a certain time. This is because each of the sides either controls the extension or retraction of a piston by directing air to one of the sides of the piston, pushing the rod back and forth. You can see this working in this visual here. Although something to note is that in our system we often use a manifold that the solenoids are mounted on top of. A manifold is just a base that we can put our solenoids on, and this base has all the holes that we would normally find in a solenoid built into the structure. This means that all we need to do to get this to work is have one tubing that connects and delivers air to the entire manifold, then place the solenoids on the slots that we want to use, and connect the corresponding holes to our pistons. This allows us to save a lot of space and organize our pneumatics better, as all the solenoids will be in one spot. Finally, we have the Rev Pneumatics hub. This connects to our PDB at the same place where the VRM does. It powers all of our pneumatics devices and is connected to CAN so that we can control our pneumatics devices from the code. All of our pneumatics are powered through this module, not through the PDB. Also note that we can plug it into our laptop through USB-C to configure our Rev Pneumatics hub directly on the Rev hardware client, allowing us to set things like CAN IDs. Now that we know the parts, let's see how they are implemented. First, we need to understand the FRC regulations. According to official regulations, our stored air pressure needs to be 120 psi or less, and our working or usable air pressure needs to be 60 psi or less. Working air simply refers to air that is actually being used to operate our pneumatic devices, such as pistons. So our system needs to be split into two parts, one with our stored 120 psi and the other with our working 60 psi. This can be achieved by separating the two parts of the system with a pressure regulator, in which the output pressure is set to 60 psi or less. We can call the sides the high side and the low side. On the high side, we want our compressor, air tanks, and any devices that regulate the pressure to less than 120 psi. See if you can recall the names of these. Then, on our low side, we have our solenoids and pistons, or our devices that actually do work. As long as we separate our pneumatic system like this, the configuration doesn't really matter. And although there are some specific places where order does matter, these usually make sense. For example, we always put the piston after the solenoid because the solenoid controls the air that goes into the piston. That's pretty much all of how to create an FRC pneumatic system. We created one in the lab the other day, so here's a video of it working. Okay, now I'll go. Yeah, you should enable the compressor.
I think I did this wrong.
No, it's fine. If you didn't catch all of it, feel free to rewind the video to specific parts, or ask me if you have any questions. In the next video, we'll be learning and reviewing programming by examining the code I wrote to run the pneumatic system you just saw.